assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, to start off, it's very important to understand the geometry of the situation here. So the wire's magnetic field is directed vertically upwards. So vertically upwards is the B sub W, wire's magnetic field. The X, and then the wire, and then the net force, the net magnetic field, sorry, has an X component directed in the X direction and a Y component, which we'll find out. But the Earth's magnetic field is directed 44 degrees below the horizontal. Okay, and so this angle theta is the direction, is the angle between the horizontal and the net magnetic field. And so this is what we have to find here, the net magnetic field. So let's get started. First of all, the easy stuff. Earth's magnetic field strength is 5 times 10 to the negative 5 Tesla. The magnetic field due to the wire is mu naught over 2 pi times I over r. So this is 4 pi times 10 to the negative 7 over 2 pi. And so units work out for this one. I'm not going to write them down. Times 24 amps over 0.2 meters. So you get 2.4 times 10 to the negative 5 Tesla for the wire. The wire's magnetic field strength. And then the net magnetic force, the net magnetic field strength in the X direction will actually be the X component of this, of B sub n. So of B sub E, I should say, Earth's magnetic field. So it'll be B sub E times cosine 44 degrees, which is 3.6 times 10 to the negative 5 Tesla. And then finally, Bn, the net magnetic field in the Y direction, Bny, will be, first of all, there's a component acting upwards. That's the magnetic field due to the wire, minus, because it is below the acting below the horizontal, that's B sub Earth times sine 44, the vertical component. So this gives you, so basically you have 2.4 times 10 to the negative 5 minus 5 times 10 to the negative 5 times sine 44. This gives you negative 1.7 times 10 to the negative 5 Tesla. And so now you can find the net magnetic field. So net, B net, or B sub n, to be consistent with the notation here, B sub n, which is what we want, is actually by the Pythagoras theorem, B sub nx squared plus B sub n y squared, the vertical component and the horizontal components squared. So this will be equal to the square root of B sub nx, which we found to be 3.6 times 10 to the negative 5 Tesla squared, plus B sub ny, which is negative 1.07 times 10 to the negative 5 Tesla squared. This gives us a net magnetic field strength of 3.8 times 10 to the negative 5 Tesla. And then to find theta, the angle, the direction, so the angle from the horizontal, below the horizontal, that'll just be arctan of y, of B sub ny, B sub ny over B sub nx, the vertical component over the horizontal component. So this will be arctan of negative 1.07 times 10 to the negative 5 Tesla over 3.6 times 10 to the negative 5 Tesla. So this gives you an angle of 17 degrees below the horizontal.